Welcome to episode 67 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data and AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Today, we're diving into one of the favorite tools of researchers in AI, PyTorch.
That's right. If you've ever wondered why so many cutting-edge AI projects mention PyTorch, stick around. We're unpacking what makes this tool special.
Let's start with the basics. PyTorch is an open-source library primarily used for deep learning, essentially a way for computers to learn from data and perform tasks like recognizing images, understanding speech, or even writing text.
And it's not just for lab experiments. Companies are using PyTorch to build practical applications that touch everything from self-driving cars to healthcare diagnostics.
To understand why PyTorch stands out, picture deep learning like building a complex Lego structure. You have many small pieces, or neurons, stacked and connected in clever ways to form a model. These models learn by adjusting connections based on data they see.
Right, and PyTorch offers a very flexible way to build these Lego structures. Unlike some older tools that felt rigid, PyTorch lets developers change parts on the fly, which makes experimenting and improving models faster.
Historically, PyTorch was introduced by Facebook's AI Lab in 2016. It gained rapid popularity because, unlike earlier libraries such as TensorFlow, which initially followed a static computation graph approach, PyTorch uses dynamic computation graphs.
Which basically means it's more intuitive for people who want to try ideas quickly. I've seen teams move from concept to prototype in days instead of weeks because PyTorch's design feels more like regular coding.
Exactly. To clarify the term dynamic computation graph, think of it as a flowchart that's built as the model runs, step by step. This lets you inspect or modify the flow during execution.
This dynamic nature is a huge win in industries like finance, where models often need tweaking based on new data or regulations. I remember a bank upgrading their fraud detection system. The team used PyTorch to quickly test new ideas without rewriting big chunks of code.
At the core, PyTorch provides tensors. These are multidimensional arrays, similar to spreadsheets but with more dimensions, that hold data. It also offers automatic differentiation, which means the library can compute gradients automatically, a vital part of training neural networks.
For anyone managing AI projects, this transparency and training is helpful. If a model's predictions go wrong, teams can dig in more easily because the framework doesn't hide what's happening under the hood.
Another important aspect is PyTorch's ecosystem. It's not just the base library. There's torchvision for image tasks, torchaudio for sound, and many other extensions. This makes it adaptable across fields.
To give a quick example, in healthcare, I've worked with startups using PyTorch-based tools to analyze medical images. One company automated tumor detection, cutting review time down significantly, which shows how the tools reflect directly on real-world impact.
Something else worth mentioning is PyTorch's role in research. Because it's flexible and Python-friendly, many researchers prototype new models with it first. This often means the latest AI breakthroughs come with PyTorch code.
But sometimes being so research-focused raises questions among business teams about stability and support. In my experience, PyTorch has matured remarkably. Many large-scale deployments now run in production environments confidently.
That's true. Facebook's own products rely heavily on it, and major cloud providers offer PyTorch-compatible services, making it easier to scale.
And from a consulting standpoint, that means PyTorch isn't just a buzzword. It's a practical technology businesses can adopt and rely on.
To give a more concrete analogy, imagine comparing PyTorch to driving a car with manual transmission, giving you fine control and immediate feedback, versus an automatic that can sometimes feel less connected. For researchers and developers, that manual feel means greater flexibility.
But for managers, that might sound intimidating. The key is having the right talent who understand both the tool and the business problem. When that's in place, PyTorch becomes a powerful lever for innovation.
Let's also touch briefly on model deployment. While PyTorch started mainly as a research tool, platforms like TorchServe now enable deploying models to production reliably.
This deployment capability lets companies move faster. For instance, an automotive client used PyTorch models to improve real-time object detection in driver assistance systems. The quick turnaround from prototype to in-car deployment saved them months of development time.
Wrapping up the theory side, PyTorch is beloved by its intuitive design, dynamic computation graphs, and strong ecosystem, all contributing to accelerating AI model development and experimentation.
And on the ground, it translates to faster innovation cycles, flexibility in handling diverse problems, and a proven path from research to production.
Time for our key takeaway?
Sure. For me, PyTorch represents the bridge between cutting-edge AI research and practical, impactful applications. It's a tool that empowers teams to move quickly and iterate often.
I'd highlight PyTorch's role in making deep learning more accessible and flexible. Its design encourages exploration, which is crucial as AI continues to evolve.
Looking ahead, in our next episode, we're diving into Hugging Face, that exciting hub for natural language processing models and tools. If you're intrigued by language AI, you won't want to miss it.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your questions or thoughts on today's episode. Maybe we'll feature them in a future show.
Until tomorrow, stay curious, stay data-driven.